Hi everyone. Alright, we will get started on this practice test with the solutions. The first two are graphing rational functions. Number one, it says use the function f of x equals 2x squared minus 6x minus 8 over x squared minus 4 to provide the information asked for below. Alright, well the first thing A is asking if there's any holes, and to really find that out we're going to have to factor the numerator and denominator and then simplify. And the first thing I might do is 2 is a common factor of 2x squared, negative 6x, and 8. So I'll write 2x squared minus 3x minus 4, and then write x squared minus 4 is x plus 2 times x minus 2 for difference of squares. And then write 2 times x minus 4 times x plus 1 over x plus 2 times x minus 2. Nothing's canceling. So are there any holes? The answer is no. If something cancels, then we deal with a hole. Now B, the zeros, that's the numerator. Set the numerator equal to 0, and the numerator, I'll leave it in its factored form. 2 times x minus 4 times x plus 1 equals 0. If I divide through by 2, I have x minus 4 times x plus 1 equals 0. And when you solve x minus 4 equals 0, or your other solution is x plus 1 equals 0, you get your zeros of the function. X equals 4, x equals negative 1. Those are the zeros. Part C, is or are the equations for the vertical asymptotes? Well, in this one, we want to set the denominator of the function, of the rational function, equal to 0, and I'll leave it in its factored form. X plus 2 times x minus 2 equals 0, so x plus 2 equals 0, or x minus 2 equals 0. When you solve, x equals 2, that's one vertical asymptote, that's negative 2 on this one. X equals 2, that's the other vertical asymptote. Alright, part D, the horizontal asymptote. We have 3 conditions to look at. And on our condition, the degree of the denominator is 2, and it's equal to the degree of the numerator. Okay, our horizontal asymptote, when the degrees are equal in the numerator and denominator, if we take the lead terms, and I'm going to look at the original problem, it's a little easier. 2x squared over x squared is equal to 2. So y equals 2 is, these are vertical asymptotes here, is a horizontal asymptote. Now, the critical value number line. I'm going to put these 4 values here on there. The negative 2 is a vertical asymptote, and positive 2 is a vertical asymptote, and 4 is a 0, and negative 1 is a 0. And then I'm going to do test points. This is especially important if you don't have a graphing calculator. But I still want you to know how to do it, even if you are going to be using a graphing calculator. Now, I'm going to use negative 3 for one of my test points, left of negative 2. Between these, I'm going to use negative 1.5 for one of my test points. I'm going to use 0 for a test point. I'm going to use 3 for a test point. And I'll go out here a little bit and use 5 for a test point. And that, I'm looking for the approximate locations between all our zeros and our vertical asymptotes. So, when I test negative 3, and it might be easiest to test with the factored form. And when I test negative 3, I'm looking at 2 times negative 3 minus 4 is negative 7. Negative 3 minus 1 is negative 2. And negative 3 plus 2 is negative 1. Negative 3 minus 2 is negative 5. And 14, that's 28 over 5, which is, what, 5.6. I'm going to write 5.6 there. Now, at negative 1.5, I have the 2, and I have negative 1.5 minus 4 is negative 5.5. Negative 1.5 plus 1 is negative 0.5. Negative 1.5 plus 2 is negative 0.5. Nope, positive 0.5. Negative 1.5 minus 2 is negative 3.5. Okay, I know the top. 2 times negative 0.5 is negative 1, times negative 5.5 is positive 5.5, and this is half of negative 3.5, which is negative 1.75. Okay, that looks to me to be about negative 3 or so, but I'm going to go ahead and just take 5.5 divided by 1.75, whoops, well, I'm going to make it negative. So negative 3.14 caused me to look for a second. It looked like pi there. Negative 3.14 with the test point of negative 1.5. Now, test point of 0, if I look at the original, that becomes 0, that becomes 0, and that becomes 0. So I got negative 8 over negative 4, so that is 2. I got that one. I'm not going to write that one down. Test point of 2 times 3 minus 4 is negative 1. 3 plus 1 is 4. 3 plus 2 is 5. 3 minus 2 is 1. Negative 2, that's negative 8 over 5. I'm looking at negative 1.6. I'm kind of at a weird angle right there. This is negative 1.6 there. And if I test 5 in this one, I got 2 times 5 minus 4 is 1. 5 plus 1 is 6 over 5 plus 2 is 7. 5 minus 2 is 3. So 12 over 21, I'm looking at about 0.571428. 0.571428. Okay, and I'll just use about 0.6 up there. So let's put in our vertical asymptotes. Negative 2 and positive 2. And y equals 2 is a horizontal asymptote. And our zeros at negative 1 and positive 4 are good to know. Test point, I had negative 3 and 5.6, so right around there. All right, with these asymptotes, that tells me we're doing this. We're close up top and we're close to the left. We get closer each time. Okay, the test point of negative 1.5 is negative 3.14, right around here. The test point of 0 is 2. Now, we had a good question. This horizontal asymptote does not apply to the middle part. It only applies to the far right and the far left. Okay, so I'm seeing that this is doing close here, comes up, goes through here, and then gets close up here to this asymptote. And then, okay, got that 0 graphed. 3 is negative 1.6. Alright, it's right around there. Get that 0, and 5 was about 0.6, so right around here. So I think we're close down here. We come up, we cross the x-axis right there, and then we come up and we get close there. Alright, there is the first one. I will do the second one on a new video.